Hi everyone, welcome back to our channel. Today we are going to see the formulas of converting an delta network into an star network. This is called delta to star transformation formula. Actually in the problem R1, R2, R3 which constitutes like an delta. So why it is called delta means it seems to be like an mathematical delta. That's why this network is called delta network. So R1, R2, R3 are given. We need to convert this delta into an star. The elements are Rx, Ry, Rz. It's very simple to convert. Let's try to see the formulas. Okay, so here the given values are the red color values are given, so I want to find out this black color values. Okay, so actually this Ry will be available at this point, and here we are going to have the neutral. Okay, so what is this value of Rx? Okay, so this is the value of Rx. So now how to find the value of Rx? Rx is equal to, so Rx, you see this black color resistance, which is an unknown resistance, is connected to this node. To this node, what are the elements connected? R1 as well as R3 are connected. So just do the product, which is nothing but R1 into R3 divided by the sum of remaining branches. What are those remaining branches? Which is nothing but R1 plus R3 plus R2. So successfully we find the value of Rx. So now we need to find out the next black color resistance where red color values are given. Let us try to mark this value as Ry, which is nothing but this value is nothing but Ry. So what is the value of Ry is? Ry is equal to, you see this black color resistor is connected to this point. To this point, what are the resistors which are connected? One is R1 and next one is R2. So product of these two resistors, which is nothing but R1 R2 divided by R1 plus R2 plus R3 is the value of Ry. So similarly, I'm going to connect a one more resistor where this is nothing but Rz. So what is the value of Rz? Is nothing but Rz is equal to, this black color resistor is connected between to this node. To this node, what are the resistors connected? R2 and R3 is nothing but R2 R3 divided by R1 plus R2 plus R3. So successfully we find the values of Rx, Ry, Rz. Very simple. So red color values are there, and we need to find out the black color values. The black color resistor is nothing but star network, which is product. I mean, this black is connected to two reds, which is R1, R3 divided by plus R2. So this black is connected, this black resistor or the center resistor is connected to R1 into R2 divided by R1 plus R2 plus R3. This black color is connected between R2, R3 divided by R1 plus R2 plus R3. Let us try to do an problem on this model such a way that you will be very clear about how to convert a delta to star network. Okay, so now I'm trying to construct a star network and delta network. You see here I'm taking a problem. From this you'll have one derivation. Okay, so problem is, so I have three resistors, is one of the previous gate problem. So the delta values given are 1 ohm, 1 ohm, 1 ohm. The red color values, this is in the form like an delta. You need to find out star. So star means, already I told, we need to find out the this black color resistor. Okay, what I am drawing now. So this black resistors we need to find out. Let's try to mark these terminals as X, Y, Z. So now I am drawing as is X, Y and Z. So this black resistor I am drawing here. This is the one black resistor. This is the another black resistor. This is another black resistor. Now this is like an star. So how to find this black resistor value? So this black resistor value, how to find out? The formula is, so to this black resistor, what are the resistors which are connected red color one, which is nothing but 1 into 1 divided by 1 plus 1 plus 1. So this is nothing but 2 by 3 ohms. Next one. So coming to this branch, this is the element. Okay, so this element we need to find out. How to find this resistor is, so this black color resistor is connected between these two known resistors. So what are the known resistor is 1 into 1 divided by 1 plus 1 plus 1. So 1 plus 1 plus 1, which is nothing but 2 by 3 ohms. Next, I want to calculate this black color resistor, where if you can label it as some RZ, this you can label it as some RX, this you can label it as some RY. So this black color resistor, I need to find out. How to find this value is, so there are two resistors which are to this black. How many reds are connected? Two reds are connected. So I can write down 1 into 1 divided by 1 plus 1 plus 1, which are nothing but 1 plus 1 plus 1, which is nothing but the RZ value is 2 by 3. So you can see here, so the original, sorry, a small mistake. So this is 1, directly 1, 1, 1, 1. So you can see here all the resistor values are 1, but here the each resistor value is scaled 1 by 3 times. How many times? Is 1 by 3 times. So when you are connecting a delta which has equal resistors, will be transformed into an with a scale of 1 by 3 times. 1 into 1 by 3 is nothing but 1 by 3. This 1 into 1 by 3 is how much? 1 by 3. This 1 into 1 by 3, which is nothing but 1 by 3. So this is how to apply the formula of finding out Rx, Ry as well as Rz. Okay, so very simple. The black color resistor we can find out product of remaining two resistors divided by sum of R1, R2, R3. This is how to convert a delta to star transformation formulas. So hope you understood. So any problem, now we can convert delta to star by using this formula. I thought this is addition, that's why I written 2, but actually this is a product. So this is how to convert a delta to star is obtained when those are equal values. In the gate, it will be asked if a delta is having all equal resistors, and what is the equivalent star of each resistor? This is nothing but R into each branch is how much? R by 3. This is how much? R by 3. This is how much? R by 3. So this is what the gate question generally will get. Hope you understood the video. If you find the video is useful, please like and share with your friends. If you have any doubts, let me know in the comment section. Thank you for watching the channel. If you are watching the channel for the first time, subscribe the channel. Thank you for watching. Yours obediently, Ram.